Welcome back. Today we are going through lesson 4.6, which is all about solving quadratic equations using square roots. So when we've solved before, we've factored, but solving by the square root method is something we use when there's no x term in our equation. So we have the x squared part and we have a constant of some sort, but there's no x term in there. We can also use this anytime the quadratic is in vertex form. So remember, vertex form looks like this. And so we can isolate that x value using square roots. So the steps to do this are to isolate whatever's being squared. So the x part, we're trying to get it alone using our inverse operations. And then once we get that part that's being squared isolated, we're going to square root both sides and simplify anything. So remember, to simplify, there cannot be a square root in the denominator of a fraction, and they need to be rationalized to do that. All right. Let's start with some quadratics here, and we're going to find real solutions for these ones. So we're going to start by isolating that squared term here. So if I write it out, to isolate that, I'm going to have to multiply by 3/2 to start with on both sides. When I do that, I'm left with x squared equals 36. So I've isolated the term that's being squared. Now I'm going to square root both sides. And I'm going to get that x could be plus or minus 6, because remember, 6 squared and negative 6 squared are both 36. Okay, let's look at example 2 here, or example B. So in this one, the quantity being squared is already isolated. I don't need to move anything away from that quantity, so I'm going to square root both sides to start with. So I have x plus 2, and then remember, when I square root 1, I get plus and minus 1. So now I need to finish solving for x, so I'm going to subtract 2 from both sides. And when I do that, 1 minus 2 is negative 1, and negative 1 minus 2 is negative 3. So my exact solutions are negative 3 and negative 1. For this one, we don't need any approximate solutions because they're nice integer values. Okay, for C here, I need to again isolate that variable. So I'm going to add 10 to both sides. And I am going to get that x squared equals 12. And so when I square root both sides, I get that x is plus and minus the square root of 12. And I need to simplify that. So remember, the square root of 12 can be simplified into the square root of 4 times the square root of 3. So I get that x is plus or minus 2 root 3. So those would be my exact solutions. Negative 2 square roots of 3 and positive 2 square roots of 3. And then my approximate solutions, if I type those into my calculator and got the decimal version, I would get about negative 3.46 and positive 3.46. So when they're square root answers, we can find more approximate solutions. Okay, let's try one more here. We're going to isolate that quantity squared again. So I am going to get 4 times x minus 1 squared equals 8. Then I have to divide out this 4. So I'm going to get x minus 1 squared equals 2. And now I've isolated that quantity that's being squared. So I'm going to square root both sides. So I get that x minus 1 equals plus and minus the square root of 2. Square root of 2 cannot be simplified, so I'm just going to add 1 to both sides. So that leaves me with solutions of 1 plus and minus the square root of 2. So my exact solutions are 1 minus the square root of 2 and 1 plus the square root of 2. And so again, if I type those into my calculator and get approximate answers, I get about negative 0.41 and 2.41. So now we've got our real solutions. Sometimes, though, we want to remember that we're going to get complex solutions. So remember that when you square root a negative number, we write it as an imaginary number. So for example, if I have the square root of -2, I never want to leave a negative inside my square root. I would write it as I square roots of 2. Or if I have the square root of a perfect square, I would rewrite that as 2i. So we want to remove those imaginary numbers to get them simplified. So let's look at what that might look like here. So again, we're still going to isolate that quantity squared. The only thing that changes here is once we get to taking the square root. So here I would have 3x squared equals -27. I would divide by 3 and get that x squared equals -9. So I've isolated my squared term. Now I'm going to square root it. And we can see there that we get the square root of -9. So the square root of 9 is going to be plus or minus 3. And since it's a negative, we're going to put an I on the end. So those would be my exact solutions, -3i and +3i for my x values. Okay, let's look at the second one, written in vertex form. So I'm going to isolate that quantity squared. And I would get that x plus 3 squared equals -2. I'm going to square root to isolate the x a little bit further. And again, that's I square roots of 2, and we put a plus or minus in front of it. So now to get x alone, I'm going to subtract 3. And my solutions, therefore, would be -3 minus I square roots of 2 and -3 plus I square roots of 2. Okay, let's look at 2 more that might have some complex solutions here. So starts the same. We're going to isolate the quantity squared. So we get x plus 4 squared equals -48. Now I have to square root that. So x plus 4 is what's left on the left side. Now the square root of -48 can be simplified. So that is the square root of 16 times the square root of 3, and it's got that negative with it still. So when I simplify that all the way down, I get plus or minus 4i for the square root of -16, and then the square root of 3 we leave. So then I subtract 4 from both sides, which means my solutions are going to be -4 minus 4i root 3 and -4 plus 4i root 3. Okay, let's look at one last example here. So subtracting 1 from both sides, we get 3x squared equals -16. So we have to divide by 3 here. So I would get x squared equals -16 thirds. Since I've isolated my squared term, I'm going to square root both sides. And then it gets a little tricky here. So when we have a fraction, we're going to separate the numerator and denominator. So the square root of -16 is plus or minus 4i. And then we have the square root of 3 in the denominator. So again, we can't leave a square root in the denominator. So we need to rationalize by multiplying by it in the numerator and the denominator to get our answer. So we still have plus or minus 4i root 3 in the numerator and 3 in the denominator. And then we just check and see if we can simplify 4 thirds. We can't in this case. So my 2 solutions here are going to be negative 4i root 3 over 3 and positive 4i root 3 over 3. Okay, we're going to jump into our practice problems now. I'm going to go through some of these all the way through, and then other ones I'm just going to show you the answers. So I'd encourage you to pause the video, try all 8 of these practice problems on your own using the examples we did, and then come back here and check your work. So for these ones, they want us to solve each quadratic and then state the exact and approximate for any real numbers. So we only do that for the real answers. If they're complex, we don't need to do that. Okay, so number 1, we need to isolate that x squared. So I'm going to subtract 6 and get x squared equals negative 81. Now that I've isolated it, I square root both sides, and I get x equals square root of negative is going to give me I. Square root of 81 is 9. So I have plus or minus 9i. So my solutions are negative 9i and positive 9i. Okay, number 2. Using our inverse operations, we're going to isolate x squared. Divide by 7. Get x squared equals 12. Square root both sides. And I would get that x equals plus or minus, let's see, 12 is the square root of 4 times the square root of 3. So that would be 2 square roots of 3. So my solution, since this is real, remember we need to write out the exact, which would be negative 2 root 3 and positive 2 root 3. And we need to write out the approximate. So I would type negative 2 square root of 3 into my calculator. I get about negative 3.46 and positive 3.46. Okay, these next two, I'm not going to go all the way through, but I will tell you the answers. So for number 3, you would get the solutions of negative I root 14 and positive I root 14. Same thing with number 4. I'm not going to go all the way through it, but you would get exact answers of negative 2 root 2 and positive 2 root 2. And the approximations of that would be negative 2.83, positive 2.83. Okay, number 5, let's go through this one. So I'm going to square root both sides. That's going to leave me with x plus 2 equals plus and minus. Square root of 9 is 3, and with a negative it would be 3i. So then I am going to isolate the x by subtracting 2. So my solutions would be negative 2 minus 3i and negative 2 plus 3i. Okay, so number 6, the answers you're going to get, I'm not going to go through it, but you would get solutions of negative 3 minus I root 7 and negative 3 plus I root 7. Same thing for number 7 here. Let's start by subtracting the 5 from both sides. So we're going to get 16 equals x minus 2 squared. Now that I've isolated that quantity squared, I'm going to square root both sides. And that's going to give me plus or minus 4 equals x minus 2. So I need to add 2 to both sides. So remember, when we have real solutions here, we're going to add 4 plus 2 and get 6. And we're going to add negative 4 plus 2 and get negative 2. So 2 real solutions there. Those are exact by themselves, so we don't need to do anything else with them. Okay, finally, for number 8 here, we're going to go through it all kind of. So we're going to isolate the quantity being squared. So subtract 10 from both sides. And then divide by 2 on both sides. So we're going to get 3x minus 5 squared equals negative 20. Square root both sides and get 3x minus 5 equals, now we have to simplify this, so we are going to have, that would be the square root of negative 4 times square root of 5. So that's going to be plus and minus 2i root 5. Now I've got some more work to do to isolate that x. So I'm going to add 5 to both sides and get 5 plus or minus 2i root 5. And then I'm going to divide by 3. So my final solutions here are going to be 5 minus 2i root 5 over 3. and 5 plus 2i square roots of 5 over 3. All right, that's how we solve quadratics using the square root method. We'll see you next time.